geometry, lesson 91, 92, part 2. We're going to pick it up with question number 10. Now, I showed the other class, I'll show this class the same thing, that there are two methods to finding the answer to number 10. There's the old school method, right? The old school method would have me draw a right triangle, right? It says if cosine theta is 0.57. So let's say that is my angle theta. Cosine is adjacent over hypotenuse, right? So 0.57 is a fraction of 57 over 100. Does that make sense? Right? So we would end up saying cosine theta equals 57 over 100. I don't even think that that reduces. And from there, I would write 57 here. I'd write 100 here, correct? And so if I wanted to find sine, what I have to find is this guy right here. And I can do that using the Pythagorean theorem. I can take 57 squared, right? We can do 57 squared plus b squared equals 100 squared. Okay, let's do that. Let's see that it works. Okay, 57 squared is probably a big number. Okay, 3,249 plus b squared equals 100 squared. Okay, which is what, that's 4 zeros. Okay, we're gonna, let's see, out of that we would end up doing what? We got, what doesn't seem, oh, nope, 5 zeros. Right? No, 4 zeros. 57. Why is 57 squared bigger than 100 squared? Oh, that's right. So I only have 3. Good. All right, so we want to take, and we want to subtract 3,249. Okay, so we're getting b squared equals 6,751. Square root that. Square root 6751. And so b equals, we'll call it 82.16. All right, so that's 82.16. But notice we don't want just that. We want to know what sine is. Sine is opposite over hypotenuse. So sine is 82.16 divided by 100. So we get sine equals, or sine theta equals 0.82. Is that pretty close to being accurate? The only thing is that our answer is 0.83. We're close, but we're not exact. Okay? And that's a lot of steps. Okay? And I had to draw a triangle. I had to know where 57 went, had to know where 100 went, I had to know several different things, correct? Okay? Whereas if I use the formula that we've learned today, which is sine squared theta plus cosine squared theta equals 1, then I start off with sine squared theta plus 0.57 squared equals 1. Okay, we take 0.57 and square it. Okay, I get 0.3249, right? And we want to use all 4 decimals. We're going to subtract, so we get sine squared theta equals 1 minus 0.324. 0.6751, and then my last step is to square root that. Square root of 0.6751 is 0.82. All right, well, we'll still be, I don't know why I got 0.83 in the other one, but... Oh, did I know where I messed up at? No, number 10 is 0.57, so looks like in my work for, oh, that was number 9. I don't guess, here, let me look at the answer key for number 10. I'm looking at the wrong thing. Yeah, 0.82. So this is my answer. And so we did wind up with the right answer the other way, but does this require less knowledge? Yeah, I didn't have to draw any pictures. I just had to plug my numbers into my formula. And they can do the same thing by giving you sine and solving for cosine. Does that make sense? Okay. Jose, you still with me? No. All right. All right, number 11. Rico and Jane. Rico and Jane. Okay. Standing on a bike path looking at a tree. Obviously, Rico and Jane don't have smartphones. That's all we're doing. As shown in the diagram below, Jane is 2 times as far from the tree as Rico is. What is the approximate ratio of Jane's distance from Rico to her distance from the tree? It's kind of an odd question to kind of be thrown into all of this. Where does this question come from? Number 11. It comes from lesson 91 is what it says. Okay. All right, so if her distance, what is the approximate ratio of Jane? Jane is 2 times as far from the tree. All right, so this is 2x, right? 2 times as far from the tree as Rico is. So x. We should begin to see our special right triangle ratios here, right? So what would the bike path actually be? X radical 3. Very good. All right, where what I'm actually looking at here is this is a 30-degree angle. This is a 60-degree angle. I have my 30, 60, 90 special right triangle ratio. So we want to know the ratio. What is the approximate ratio of Jane's distance from Rico? Jane's distance from Rico is radical 3, right? To her distance from the tree, 2. All right, we don't actually have to include the x's because the x's cancel out. So my ratio is radical 3 to 2. You could write it like that, or you could write it like this. Is that doable? Okay. All right. All right, number 12. Okay. The vertices of quadrilateral are shown. Is this a parallelogram? Is it a parallelogram? Nope. It's not. Why is it not a parallelogram? Well, opposite sides would have to be parallel, right? Okay. So you could find the slope from x to y, right? From x to y, it's going what? Up how much?
4.
From 6 to 8, it's going up 2, right?
Yeah.
And from 7 to 11, it's doing what? What's the distance from 7 to 11?
4.
4. So it has a slope of 1/2, right? Correct? All right. Let's look at from W to V. W has a raise of what from 2 to 6?
From 2 to 6.
Oh, sorry. I'm looking at from W to V. So I actually got to change this. W to V. So it's got a rise of 1. All right. So far, that's not a problem. All right. But from 6 to 9. 3. So at that point, I could stop, right? Because those two opposite sides do not have the same slope, right? And in a parallelogram, both pairs of opposite sides would have to have the same slope. So if I don't have one pair, it doesn't even matter, right? The best it could be is if the other two sides were parallel, I could call it a trapezoid, right? But it's not a parallelogram. All right, here 13. I think we have a total of 15 questions. All right, is this a trapezoid? Yes or no? I'm getting a no. It's the long no, so you go no. Okay, so E is not required. All right, why not? There's not a set of parallel sides just based upon appearance. This has a negative slope. This has a positive slope. That's a vertical slope. This is not a vertical slope, right? Pretty easy to determine that. It needs one pair of parallel sides. It has no parallel sides. Okay, 14. Are the quadrilaterals below, shown below, congruent? Are these guys congruent to each other?
No.
No. ABCD does not equal EFGH. That's as far as we need to go with that. Finally, question number 15. If tangent theta is 5 over 12, what is sine theta? This one, I would probably start off with the triangle, okay? Because it's not, they're not giving me sine asking for cosine, correct? Okay, so where do I put the 5? Where do I put the 12? Let's,
5 goes opposite, and 12 goes adjacent to it.
okay, so I still need to find hypotenuse. So I've got 144 plus 25, which is 169. What's the square root of 169? 13. Okay, so what is sine theta?
Sine theta would be 5 over 13.
5/13. Okay. Very, very good. All right, that's the end. Yes, you may.